All right, ladies and gentlemen, welcome back to the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a salami roll-up with sweet gherkin pickles, cream cheese, and mustard. Rolled up in salami, rolled up in turkey. All right, we are doing number 41 from 10.5. Okay? It asks us to find the equation of a plane containing these points that I have titled P and R, okay, that is perpendicular to the plane defined by 2x minus 3y plus z equals 3. Okay, so I've widmopoid, okay, when in doubt, make a picture of it. All right, so remember that we are trying to define the green plane, and in order to define the green plane, we need a point in the plane, and we need a vector that's orthogonal to the plane. So we obviously have the point in the plane, and we need to find the vector that is orthogonal to the plane. So how do we do that? Well, luckily, we are given this plane defined by that vector. And so we should know that the green vector is parallel, based on our picture and our reason, that green vector is parallel to the green plane. Well, the green vector is defined by those coordinates. Okay? So if I took the cross product of PR and let's call this A, that will give us the pink vector that we're looking for. So PR is, let's see, negative 1 minus 2, negative 3, 1 minus 2, negative 1, negative 1, minus 1, negative 2. Okay? So that's how we can define PR. I'm going to use RP instead, so I don't screw up so many negatives. Okay? And A, we know, is 2 so if we take the cross product of those two, okay, you get I times 1 minus a negative 6. 1 plus 6 is 7. Minus J times 3 minus 4, so that's a negative 1, plus K times negative 9 minus 2, a negative 11. So we know that that pink vector can be defined by 7, positive 1, negative 11. So we can define the plane as, okay, we can define the plane. Let's use, I need to get to my points. This is tough. 2, 2, 1. Okay, we're going to use the point 2, 2, 1. And this vector right here. And that's going to give us 7 times x minus 2 plus 1 times y minus 2 plus, minus 11 times z minus 1 equals 0. Okay, so you got 7x minus 14 plus y minus 2 minus 11z. Is that minus 11? Yep. Plus 11 equals 0. And that gives you 7x plus y minus 11z equals, let's see, negative 14, negative 16 plus, so that's a negative, so it's going to equal 5. Did I do that right? Negative 11, negative 16, plus 11, negative 5. Okay? And then, so now to see if I got that right, I need to plug the points in. So let me plug the other point in. Negative 1, 1, negative 1. Does this point satisfy that equation? You get negative 7 plus 1 plus 11. Please tell me that gives you 5. It does. And then we know that both of those points are in the plane, and we have succeeded in our task. Boom!